G'day guys, today we're looking at a pretty cool physics phenomena, and that's what would happen if we pushed one end of a very long steel bar, one that reached from Earth to almost touching the Sun. What would happen? So the distance between Earth and Sun is about 150 million kilometers, and we're going to assume that the force that we have to push this bar is very large, because the bar would actually weigh about 12 billion tons, which is a lot of weight, but we're going to ignore that and we're just going to imagine we have a force that's enough to push it. So the options are here. Do you think the far end of the rod will hit the Sun instantaneously? So as soon as it's pushed at the Earth side, it'll hit the Sun. The far end of the rod will not move. Maybe the energy might disperse, or there's two. I don't know, you got to think about it. The far end of the rod will hit the Sun after 285 days. So you'll push it, and then 285 days later, it'll hit the Sun. Or the far end will hit the Sun after a couple seconds. So have a little think, and then we'll move on to the answer. Okay, so a quick demonstration of what would happen to the particles in our steel bar as the force acts on it. So here's the force in the red arrow. And so what's going to happen is the force is going to act just on these two particles first. So the particles closest to it, it's going to act on them. In the real case, it wouldn't be two, it would be many particles, but we're just going to demonstrate it like this to keep it simple. So these two particles would be acted on, and then those two particles would act on the ones next to it. So the force is being transferred, or the energy is being transferred to the next particles. It will continue to be transferred all the way through, as you see here, until it reaches the end. So of course this takes time, and so the speed of sound in steel, so the speed of sound is essentially the transfer of energy through a medium. Our medium is the steel, and the energy is being transferred from the force. So the speed of sound in steel is about 6,100 meters per second. If we take this, that our speed, and the distance of 150 million kilometers, which is 150 trillion meters, our time can be found. So we use the equation speed equals distance over time, rearrange it, and we find that the time is about 285 days. So the correct answer was C. Now, something interesting we can see off this is, imagine we have a 1 meter ruler, and we have someone at the far end here, away from the person, and they're pushing it towards the person. Now we can figure out what is the delay from the person pushing at this end to hitting the person on this end. I don't want you to push rulers into people, but this is just an example, a real life example of what you may experience. So it's a 1 meter ruler, and the speed of sound through propylene, or the plastic that the ruler is made out of, is 2740 meters per second, 2,740 meters per second. So it's the same thing, and we find that it's actually 0.4 milliseconds. So it's a very small delay, but it is apparent. So I hope that was interesting to you guys. One thing to add before I go is that if this first option had been right, so it's instantaneous, so as soon as we move this side, hits the Sun, then we would have just found a communication system that's faster than the speed of light. So at the moment, we cannot transfer information faster than the speed of light. It's like a cap on the universe, basically, that we cannot exceed. So that's another reason why this first option is wrong, is because to our knowledge there's nothing that can transfer information faster than the speed of light. So just something to add on there.